Few more basics on fluid power. Couple of equations we need for the fluid power is the angular velocity, which you have seen before, which is omega typically, and then the linear velocity, which is v. The relationship between them is v equals omega r, and then omega can be also defined by 2 pi times the frequency and revolution per minute or revolution per second. So that's one relationship we may have to use. And then the linear velocity, which is also defined by distance by time. And then force, which you know F equals ma. And then work is force times distance, which you know that too, F times distance. And then power is the rate of work. So power is the rate of work. So force times distance, that's the work. And then rate of work is per time. So we can write S by T, which you can see the velocity. So that would be F times V. That is the power. Now in the US customary system, the unit can be written power is pound, and then force is pound, and velocity is feet per second. We can convert this to horsepower. James Watt developed the relationship. An adult horse can carry 550 pounds, and the horse can walk 1 feet per second. So the velocity feet per second. So an adult horse can carry 550 pounds, and he can go every feet per second. Feet per second. Every horse. So one horse can do that. So if you want to represent this relationship with respect to horsepower, it would be force, which is measured if it's measured in pound, and velocity if it's measured in feet per second. Then you divide by 550. The final number will come here in horsepower, because this pound feet per second, pound feet per will cancel out. Only thing will be here is the horsepower. So this one is also pound feet per second. If you want to have feet per minute, then it will be just the second and minute conversion. So if you do that, it's gonna look like this: pound velocity feet per minute, and it will look like 33,000. So that would be also in horsepower. So this is in pound feet per minute. So every adult horse can carry this much and can go 1 feet per minute, like that. You can think of like this. So that's the horsepower relationship.